All right, thanks for stopping into my talk here at the North Pole at KringleCon. Thank you, Santa, for inviting me up here. It's really exciting to be here, but man, is it cold. Man, I didn't expect it to be quite this cold. I was in San Francisco last week, and man, I would have brought the thicker gloves. Makes it hard to type, but that's all right. We'll keep rolling here. Appreciate everybody listening on Hashcat. The goal of this talk is to kind of give you an introduction to Hashcat, what it is, how it works, and a little bit of overview of the history of kind of where it came from, when it kind of went open source. We'll talk about the differences between CPUs and GPUs and how Hashcat takes advantage of those. And then we'll take a look at the different attack modes that Hashcat has. We'll talk about each one. I'll do a very brief demonstration of each attack mode and at the very end here, just so you can kind of see how Hashcat goes about processing the input you give it and guessing passwords to crack password hashes. So Hashcat has been around for quite a while, but it was closed sourced until about 2015. And at that point, it went open source and was released by its lead developer, Adam. Prior to Hashcat version 3, Hashcat had 3 different binaries that it actually used to do the password cracking. The first one was just Hashcat, and that was used to do CPU-based password cracking. And then the next 2 were OCL Hashcat and CUDA Hashcat. Now, those were based on the different types of graphics cards that the tool could work with, and the driver sets and all that required. But when we got to version 3.0 and later, Adam and the Hashcat team combined all that into a single binary, so that it would only require a single binary to run all the different password cracking capabilities, whether it's CPU-based or GPU-based. The latest version is Hashcat 5.1, which was released on December 2nd, just a few days ago. And so that's a nice little Christmas present from the Hashcat team. You can find out more about the tool itself, download the latest version, read the Wikipedia, or read the tool's wiki, etc. out of hashcat.net. All right, so as we get into looking at Hashcat, it'll do 2 types of cracking. I mentioned CPU-based cracking and GPU-based cracking. And to quickly establish the difference between a CPU and a GPU, I just want to kind of define each one, explain what they're good for. So a CPU obviously is your central processing unit. It is a general purpose processor. It does the vast majority of the processing on your computer on a daily basis. Works great for password cracking, but the speed itself depends on the number of cores that it has available and the hashing algorithm that's in use. Because a CPU tends to have less cores, it maybe doesn't process as much or as fast as a GPU does when it comes to password cracking. Now, with GPUs, the graphics processing unit is designed for high-end graphics display. And with high-end graphics display, there's a lot of math that has to be done at the exact same time. I mean, it's done in parallel. And it's doing all that math as it tries to update the screen so that the fancy graphics that you're doing either in playing video games or maybe designing something in something like AutoCAD or some other type of CAD utility is at its peak. It's at a maximum level of granularity and sophistication. So there ends up being a little bit of confusion sometimes when people try to talk about which one's faster. And it really looks a little bit more like this. So if you're going to compare it processor to processor, the core to core, in terms of the processing power, your CPU is much, much faster than a GPU. Each GPU core tends to be a little bit slower. However, if we measure what the processing units do and how they work, we would say that it's more like the purpose of a car, because we've got 2 cars on the screen here. We've got purpose of the cars to get a passenger from point A to point B. Well, the Corvette here on the left is going to go a lot faster, and it's going to get from point A to point B a lot faster, right? And it's going to take that a passenger, whatever that distance is. Now, if you had our nice little smart car over here on the right going the same path, it may not move as fast, but it's still going to get from point A to point B. But where we get the additional speed with the GPU over the CPU is actually the number of cores. Okay, so if we're comparing how many people we can move in some of a race to get people from point A to point B, it would be a bit more like this. It's more like the CPU, you get one car moving one person at a time back and forth. It may move that individual person faster, but it's competing against an army of smart cars, and with, in multiples of how many cores there. So it's each one of those cars carrying an individual passenger, and so a lot more passengers are getting moved at the same time. So when you compare a CPU to a GPU, you can end up with speeds of up to maybe 50 times faster than what you would get in terms of password cracking between a CPU and a GPU on the same hashing algorithm, right? So, interesting note there is that GPUs are actually slower. The individual cores are slower. However, with the thousands of cores that make up a GPU, you're actually moving at a really good rate. So to fully utilize that GPU, all that work gets parallelized across all the cores. Okay, Hashcat, as it does this, takes words that it's going to use to do its password cracking and guessing, and it sends those to the GPU, and then expands those words out with rules once they're on the GPU. It kind of breaks into a base loop and a mod loop. And so the base loop is kind of handled by the central processing unit, helps create that base list of words, and it sends those on over to the GPU, where the mod loop, which is run on the GPU, expands out the words, and that's where we get that additional speed with all the parallelization. Okay. Now, so we can do all that. Now, Hashcat, when it's running on CPUs or GPUs, it will do either one of those, just fantastic, right? And it'll do 4 different attack types. Well, there's really 5, but the hybrid at the bottom, it just switches which side the word list and the masks are on. So I'm going to lump those together for this slide. So the first one is the dictionary attack. This is where it just goes straight through a dictionary and goes word for word, calculates the password hash for each, and compares against the hash that you're trying to crack. In combinator mode, it goes through and it concatenates words from multiple word lists. Okay? And then, so take maybe word list 1, word list 2, combine the first word from word list 1 with all the words from word list 2. Then go down to word number 2 from word list 1, and combine with all the words from word list 2. And it goes, word by word, combining with everything between the left and the right word list at that point. It categorizes those as left and right based on where they show up on the command line. And then the last option is the brute force, and it goes through with a given character set, and per position tries all potential characters for those character sets and positions. And typically what you'll see in the brute force mode is it goes through and tries a variety of different masks. And it tries the masks that are most common to what individuals tend to see or use as their passwords. So very common mask that you'll see is maybe a capital letter, and then all lowercase letters and numbers, and then out to maybe 8, 9, or 10 characters, and then the last couple characters may be either a number or a special character. And so then it tries all the combinations where capital letter, all the lowercase of everything, and then the numbers and special characters at the very end. Very easy to set up, and I'll do a quick demo of that in just a second here. And then the last option is the hybrid attack. And so what the hybrid attack actually does is it kind of does what the combinator attack did before. And it kind of combines what I just talked about with the masks from the brute force. And it lets you define those on the right and left side. So with the hybrid, where you end up with is you'll start with that base list, right? And then from the base list, you can add masks to the other side, or to use as that the other side of that dictionary, allowing you to brute force, and let's say all of the characters up to 3 in length, right? And it'll spit those out. So I'm going to demo that stuff real quick for you, just so you can kind of get an idea of what this looks like. This is on the slingshot image. So if you've taken 560 or would be interested in taking 560, we've got a Hashcat lab where we go deep into that at SANS. But I'm going to demo real quick Hashcat 4.1.0, and I'm going to do, I have 3 different word lists here. Okay, and so I'm going to get a quick idea of what's there. 3 different word lists. There's only 2 words in each one, just to keep this simple. So I've got dog, cat, apple, banana, car, and truck. Okay. So if we take a look at what we do with Hashcat, I'm going to do Hashcat. I'm going to pipe it through to less, just so you can kind of see where we're starting here. So this is the help file, and we're going to give it an attack mode. M gives us the hash type, meaning the type of hash that we're going to break. And then there's a lot of other options in here to fine-tune Hashcat. But to do the very basics, we get to, let's see, the different hash modes. Each hash mode has a number. Get past all the hash modes here and show you the attack modes and their numbers. All right, so here's our attack modes. So we have the straight, which straight is also the same as a dictionary attack, as I mentioned. 1 is a combination, meaning it's going to take the combination of 2 different word lists. Brute force will actually do a brute force based on a specific mask. And then 6 and 7 are the hybrid attacks that I was talking about. And the only difference there is which side the masks end up showing up. Okay. So real quick, if we just do Hashcat, now I'm going to do something called std out. And this is just so you can see what words Hashcat generates as it goes through with these different types of attacks. So for instance, if I do a standard out and I do an attack mode of 0, and then I give it word list 1. Okay. You can see it basically goes through. You can ignore that error, but it tries each word exactly as it shows up in the password file. Okay. Now, if I do the same thing, but I switch to the combinator, so this is a combinator attack, and I can now give it the second word list. And you can see it went word by word in the first word list and appended the words from the second word list to the end of it. So we have dog, apple, dog, banana, cat, apple, cat, banana. Okay. If we do the exact same thing here, we're going to take a look. We can mix it up completely by switching which side these guys show up on. Right. So this one. And you can see everything is then completely inverted, right? So we start with the fruits and then we have the animals after that. Okay, that's cool. Now, we can go back up to the straight attack. So if I'm doing a straight attack with a dictionary, I can also apply rules in Hashcat. Okay, and there's a few different rules that it will allow you to do. All right, so this is the best 64. It's one of the most basic rule sets available in Hashcat. But what you'll see is it's going to take that word list 1, which is dog, cat, and it's going to apply a whole bunch of different rules to that word list. And what you'll see is variations of dog and cat pop out with all sorts of substitutions and things appended to the beginning, the end, etc. So, all right, so we're going very quickly there. But if I go back through here, you can see it's appended numbers, it's doubled the word, right? It doubled the last letter and then doubled the word, right? Tripled the last letter of the word, right? Substituted an L for the D. You can see it just does all sorts of mangling to try different things. Now, if I want to know, okay, roughly then, redirect standard error to dev null so it doesn't get counted, and then type it through to wc-l. You can see that my 2 words were then turned into about 154 words. Okay, cool. Now, if we come back up here, let's go back to here. We're going to do a brute force. Now, the brute force is going to be a little bit different here. I'm not going to let this run for very long, but it's going to run and it's going to spit some stuff out, but it'll begin iterating through, and you'll see the changes as it goes. Maybe it won't let me do that on the standard app. There we go. Needed a mask. Okay, so the 3 that I gave it just said try every single type of character and do 3 of them. Okay, and so I could do the same thing here by doing lower. Nice, we have it's going to do lower, a lowercase, and then a digit. Actually, I'm just going to shorten this up to just 2, just so you can see the output without it being too much. Okay, and so you can see it went straight through the alphabet, and then it went number by number through the alphabet as well. It spits all that out, so you can brute force character by character. Okay, cool. So the last piece here is the combination. So if I give it word list 1 and I give it a digit. So what this is going to do is take word list 1, which is dog cat, and it's going to append every combination of 0 through 9 to the right side of the word list. It's going to think for a second and spit that out, and then you can see that it goes through word by word, number by number. You can see the order isn't quite what you would expect, but it still gets through every single one of them. And then you can do other interesting things here too. So for instance, we could add a J, which is going to apply a rule and say, let's say we want to append a dash so that it's the word dash and then just do 1 number so that it's nice and easy to see the output. There we go. All right, so that's the basics of kind of how Hashcat works. You can then use this. Now this is printing all that out to the screen, but the only thing that I would need to do to apply this to an actual password would be to add something like -m1000, which is a int-lm password, and then give it something like hashes.txt, which would have all the password hashes that I was trying to crack. And I hit go, and it would go through and try exactly what you see on the screen at the moment against all those password hashes. All right. Well, I really appreciate your time. Hopefully, you all have a fantastic time here at KringleCon, and enjoy the rest of the conference. All right. If you have any questions for me, please don't hesitate to reach out. This is my Twitter account and my email address. Merry Christmas, happy holidays, and have a happy New Year.